How to implement machine learning interpretability in algorithmic trading. Machine learning, ML, is a powerful tool for algorithmic trading, as it can learn from data and make predictions based on complex patterns. However, ML models are often black boxes, meaning that their inner workings are not easily understood by humans. This poses a challenge for algorithmic traders, who need to trust and control their models, as well as explain their decisions to regulators, clients, and stakeholders. In this video, I will discuss how to implement machine learning interpretability in algorithmic trading, which is the ability to understand and explain how ML models work and why they make certain predictions. We will cover three main points. Point 1. Balance complexity. Choose models with a balance between accuracy and interpretability. Point 2. Use transparent models. Algorithms that provide clear insights into decision-making are essential for trust and control. Point 3. Document decision processes. Maintain comprehensive records of model development and decisions for auditability. Point 1. Balance complexity. One of the trade-offs in ML is between accuracy and interpretability. Generally, the more complex a model is, the more accurate it is, but the less interpretable it is. For example, deep neural networks can achieve high accuracy, but they are very difficult to interpret, as they have many hidden layers and parameters. On the other hand, simple models, such as linear regression or decision trees, are easy to interpret, but they may not capture the complexity of the data. Therefore, algorithmic traders need to choose models that have a balance between accuracy and interpretability, depending on their objectives and constraints. For example, if the goal is to optimize returns, then a complex model may be preferred, as long as it is robust and reliable. However, if the goal is to minimize risk, then a simpler model may be preferred, as it is easier to understand and monitor. Some examples of models that balance complexity and interpretability are lasso regression, a linear model that performs feature selection by penalizing the coefficients of irrelevant features, making the model more sparse and interpretable. Random forest, an ensemble model that combines multiple decision trees, each trained on a subset of the data, making the model more accurate and robust, while still retaining some interpretability by inspecting the individual trees. Shapley values, a method that assigns a value to each feature, indicating how much it contributes to the prediction, making the model more transparent and fair. Point 2. Use transparent models. Another way to implement machine learning interpretability in algorithmic trading is to use transparent models, which are algorithms that provide clear insights into their decision-making process. Transparent models are essential for trust and control, as they allow algorithmic traders to verify, validate, and debug their models, as well as to communicate their rationale to others. Some examples of transparent models are rule-based systems, systems that use a set of predefined rules, such as if-then statements, to make decisions, making the model explicit and logical. Explainable neural networks that use techniques, such as attention mechanisms, saliency maps, or local interpretable model-agnostic explanations, LIME, to highlight the most relevant features or regions for the prediction, making the model more understandable and visual. Counterfactual explanations that show what would have happened if the input or the model had been different, making the model more causal and hypothetical. Point 3. Document decision processes. The third point to implement machine learning interpretability in algorithmic trading is to document the decision processes, which means to maintain comprehensive records of the model development and the decisions made by the model. Documenting the decision processes is important for auditability, as it allows algorithmic traders to demonstrate compliance, accountability, and responsibility for their models and their outcomes. Some examples of documentation are data provenance, the history and origin of the data used to train and test the model, including the sources, quality, and transformations of the data, making the model more traceable and reproducible. Model specification, the design and architecture of the model, including the assumptions, parameters, and algorithms used, making the model more consistent and standardized. Model performance, the evaluation and validation of the model, including the metrics, benchmarks, and errors used, making the model more reliable and accurate. Model explanation, the interpretation and justification of the model, including the features, predictions, and uncertainties used, making the model more understandable and rational. Conclusion. Machine learning interpretability is a key aspect of algorithmic trading, as it enables algorithmic traders to understand, explain, and trust their models, as well as to comply with regulations and expectations. In this blog post, we discussed how to implement machine learning interpretability in algorithmic trading, by balancing complexity, using transparent models, and documenting decision processes. We hope that this post will help you to create more interpretable and effective ML models for your algorithmic trading strategies. Happy trading!